You know that thing you do all the time where you sign into a brand new app using your Google or Facebook account and you never actually type in your password? It kind of feels like magic, right? Well, it's not magic, it's actually a really clever system of digital keys. So today, let's pull back the curtain and demystify exactly how modern apps get permission to use your data securely. So here's the plan. We're going to start with why sharing your password is just a terrible, terrible idea. Then we'll get into the solution, these things called tokens. We'll look at the three main ways apps get these tokens, figure out how to choose the right one, and finally wrap up with how to keep these digital keys safe. All right, first things first, we have to talk about a huge fundamental problem with how the internet works. It's all about that one password, your master key to basically everything. Okay, let's put this in the real world. You find this awesome new app that prints your photos directly from Google Photos. Super convenient. But then it asks you to log in. So, do you just type your Google password into that app? I really hope the answer that just popped into your head was a big, flashing no way. Yeah, absolutely not. Giving an app your master password is like giving a parking valet the keys to your car, your house, your office, and your safety deposit box, when all they need to do is move your car 10 feet. It's way too much power. What you need instead is kind of like a digital doorman, a trusted third party who manages access for you. So if we're not using our password, what's the alternative? Well, that brings us to the real hero of this whole story, the token. In the tech world, these temporary single-job keys are called access tokens. And they're brilliant because unlike your password, which unlocks everything, a token is designed to grant really specific, limited permissions, like permission to read photos and only for the next hour. That way, if the key ever gets stolen, the damage is seriously contained. Now, a super common format for these tokens is something called a JSON Web Token, or JWT for short. The easiest way to think about it is like a secure digital ID card. It contains a bunch of claims, which are just statements that say who you are, what you're allowed to do, and when your access expires. Okay, so our digital doorman doesn't just hand these token keys out to anybody who asks. Oh no, there are very strict procedures, or what developers call flows, for different situations. Let's walk through the three main ones. The first, and by far the simplest way to get a token, is something called the password grant. This is typically used when you're logging into an app that you trust completely, like the official mobile app from your bank, for instance. The process is really straightforward. You just type your username and password right into the app. Then, the app takes those credentials, goes to the digital doorman, the authentication server, and basically trades them in for a brand new token. Simple as that. The upside, it's easy, it's direct. But the downside, and it is a huge one, is that your actual password gets sent over the wire. Because of that, this method is a big no-no for most third-party apps, especially on the web, where someone could potentially grab your credentials. So now, let's look at a much, much safer method. This is the one that's perfect for web apps, and it's almost certainly the one you see every time you click Login with Google. It's called the Authorization Code Grant. Here's how our Smart Doorman handles this one. The Photo app doesn't ask for your password. Instead, it redirects you over to Google's actual official login page. You enter your password there, where only Google can see it. Then Google sends you back to the Photo app with a temporary one-time use code. The app then takes that code and, behind the scenes, secretly exchanges it for the real access token. The beauty here is that the Photo app never sees your password. Ever. It's the gold standard for security on the web. And it gets even better with an extra layer of protection called PKCE. You can just think of it as a secret handshake between the app and the doorman. It makes sure that even if a bad guy somehow steals that temporary code, they still can't use it. It is a bit more complex, for sure, but the security payoff is massive. Okay, but what happens when there's no person involved? No one's clicking a login button. What if it's just two computer systems, two back-end services that need to communicate securely? This is where the client credentials flow comes into play. In this case, a service has its own set of credentials, a client ID and a client secret. You can think of it like a username and password, but for a machine. The service presents these to the doorman, and in return, it gets a token that lets it talk to another service. This is absolutely perfect for automated background jobs. The key thing to remember, though, is that the token you get from this flow identifies the service itself, not a person. So it's not the right choice if a service needs to access your specific personal data. So we've got 3 different ways to get one of these token keys. How in the world do you know which one to pick? Well, it all boils down to what you're trying to do. And when you lay it all out like this, it becomes pretty clear. If you're building a super trusted mobile app where users log in directly, the password grant might work. For pretty much any web app where a user is logging in, you've got to use the authorization code flow. It's the secure choice. And for any machine-to-machine talking, client credentials is the way to go. It's all about picking the right tool for the job. All right, you've picked the right flow, you've got your token, we're done, right? Well, not so fast. Getting the key is really only half the battle. Now you have to know how to handle it properly. Here are 4 rules you just can't break. First, never, ever log the full token anywhere. That's like making a copy of your house key and leaving it on the sidewalk. Second, always use HTTPS to make sure no one can eavesdrop. Third, when you receive a token, always validate it to make sure it's the real deal. And fourth, for web apps, always use that PKCE secret handshake. And what's interesting is that good token management isn't just about security. It's also about making your app faster. If you're smart about caching things like server configurations or tokens that get used a lot, you can seriously speed things up and take a lot of pressure off your servers. So if there's one thing to take away from all this, it's that choosing the right way to get a token is absolutely critical. It's not a one-size-fits-all deal. Making the right choice is fundamental to building an app that's not just secure, but also fast and efficient. It really is about using the right key for the right lock. We've spent all this time talking about how to get these powerful digital keys, but that brings up a whole other fascinating question. Once your app receives a token, how does it actually know it's legitimate? How does it check the signature and trust the claims inside? Well, that sounds like a great topic for next time.